Who is God? Why haven't we seen him yet? Is there really such a being watching over us, listening to every whispered prayer, every desperate cry in the dead of night? These questions have haunted humanity for as long as we have been capable of asking them. They echo through every civilization, every culture, every era of human existence. Before we try to unravel the answers to these profound and deeply personal questions, let us take a careful, thoughtful journey through one of the most extraordinary minds this world has ever produced, the mind of Stephen Hawking, and understand exactly how he saw God, what he believed science could explain, and where he believed the very concept of a divine creator simply did not fit into the grand equation of existence. Stephen Hawking was not just a scientist, he was a phenomenon. Born into a world that would eventually challenge his body in the most brutal ways imaginable, he responded not with surrender but with an almost supernatural dedication to the pursuit of knowledge. While his muscles slowly betrayed him, his mind expanded in directions that most of us can barely comprehend. He spent his entire life staring into the deepest, darkest corners of the universe. And what he found there, or more precisely, what he did not find there, shaped one of the most compelling, controversial, and intellectually rigorous arguments against the existence of God that the modern world has ever encountered. But to truly understand his position, we must begin not at the end, but at the very beginning. Not just the beginning of Hawking's life, but the beginning of everything, the beginning of the universe itself. And to do that, we must start with something far simpler, the very human impulse that gave birth to God in the first place. Since human beings evolved into their recognizable form approximately 200,000 years ago, they have turned to the idea of God to fill the spaces that understanding could not yet reach. This is not a criticism. This is simply the truth of our nature. We are creatures who demand explanations. We are not built to sit comfortably inside uncertainty. When something happens that we cannot explain, something inside us reaches outward, searching for a cause, searching for a hand behind the mystery, searching for intention where there may be none. And for most of our history, that reaching hand found God. In the ancient world, before the systematic gathering of evidence, before the invention of telescopes and laboratories and equations, the natural world was a terrifying and magnificent place. Thunder would split the sky without warning. Lightning would strike a man dead in an open field. Rain would arrive and then suddenly disappear for months, leaving crops dead and children hungry. The sun would rise and set with a regularity that felt deliberate, as if some great intelligence were pulling it across the sky on a schedule only it could understand. Floods would erase entire villages. Volcanoes would swallow mountains in fire. And through all of this, human beings had no framework to understand what was happening or why. So, they created one. They built gods. They built entire pantheons of divine personalities, each assigned to a different force of nature, each given a temperament, a history, a set of desires that could be appealed to through ritual and prayer. The rain god needed to be satisfied. The sun god needed to be honored. The god of the sea needed to be appeased before any fisherman could cast his net safely. This was not stupidity. This was brilliance in its own way. The ancient peoples of the world were doing exactly what the human mind is designed to do. They were creating frameworks of meaning in the absence of knowledge. They were building mental maps for territory that had not yet been explored, and those maps served a profound purpose. They gave people a sense of agency in a world that otherwise felt completely beyond their control. They gave moral order to societies that needed rules to survive. They gave comfort to individuals who otherwise faced an indifferent universe entirely alone. But then something began to shift, slowly, incrementally, and then with gathering speed, a different kind of mind appeared in the ancient world. A mind that was not satisfied with divine explanations. A mind that wanted to look more closely, to measure, to calculate, to test. And one of the earliest and most remarkable examples of this kind of mind appeared around 300 years before the Common Era in the form of a Greek mathematician and astronomer named Aristarchus of Samos. Aristarchus was fascinated by the eclipses that periodically darkened the sky and filled ordinary people with terror. In his time, the dominant explanation for a solar or lunar eclipse was straightforward. God was angry. The darkening of the sun or the moon was a divine message, a warning from the heavens that humanity had done something to displease its creators. People would gather and pray and make offerings, desperate to restore the light and end whatever punishment they believed was being visited upon them. But Aristarchus looked at the sky not with fear, but with curiosity. He watched. He measured angles. He tracked movements. He recorded what he saw with painstaking care over many years, and what he eventually concluded was nothing short of revolutionary for his time. A lunar eclipse, he announced, was not the wrath of God. It was the shadow of the Earth falling across the surface of the moon. When the Earth positioned itself between the sun and the moon, the light that normally illuminated the moon was blocked, and what we saw from the ground was simply the consequence of that geometry. He drew diagrams. He mapped the relationships between the sun, the Earth, and the moon with a precision that astonished those who understood what they were looking at, and he did not stop there. He went further and made a claim so audacious that many of his contemporaries refused to accept it. He said that the Earth was not the center of the universe. He said that the Earth moved around the sun, not the other way around. He said that the stars scattered across the night sky were not divine lights embedded in a celestial ceiling. They were distant suns, each one a blazing ball of fire so far away that it appeared as nothing more than a pinprick of light from where we stood. This was a staggering leap of intellectual courage, and the world was not ready for it. For centuries, his ideas were largely dismissed, overshadowed by the authority of philosophers who insisted that the Earth stood still at the center of everything. It was not until many centuries later, with the work of Copernicus and Galileo, and eventually Newton, that the truth Aristarchus had glimpsed from his position in ancient Greece was finally confirmed and accepted. But the pattern he established, the pattern of replacing divine explanations with natural ones, of following evidence wherever it led, regardless of what sacred tradition insisted, that pattern became the foundation of modern science. And it is that pattern, that relentless insistence on following the evidence, that ultimately brought Stephen Hawking to his remarkable and deeply unsettling conclusion about God. To understand Hawking's position, we need to understand something that science has revealed over centuries of careful observation and mathematical investigation. The universe, in all its staggering complexity, appears to operate according to a set of rules. These rules are consistent. They apply everywhere, at all times, without exception. They do not bend for anyone. They do not change based on the circumstances of any individual situation. They are what scientists call the laws of nature, and discovering them, mapping them, expressing them in the language of mathematics has been the central project of physics for hundreds of years. Think about what a law of nature actually means. When you pick up an object and release it, it falls. Every time, without fail, whether you are in New York or Tokyo, or on the surface of a distant planet orbiting a star in another galaxy, the law of gravity operates identically. The numbers may change depending on the mass of the planet you are standing on, but the underlying principle that objects with mass attract each other holds absolutely everywhere. When you strike a billiard ball across a table, the trajectory it follows can be predicted with extraordinary precision using equations developed by Isaac Newton 3 centuries ago. Those equations work. They work so reliably that we use them to send spacecraft across the solar system, calculating the trajectories of those vehicles with an accuracy that allows them to arrive at their destinations millions of miles away after journeys of years, hitting their targets with astonishing precision. This predictability, this consistency, this elegant lawfulness of the universe, this is what Hawking spent his life exploring and expanding upon. And what he found, as he went deeper and deeper into the mathematical fabric of reality, was not God. What he found was something that, in his view, left no room for God. Not because God had been disproven in some simple, direct way, but because the logic of the universe, once fully understood, seemed to make God unnecessary. More than unnecessary in Hawking's final and most controversial argument, the laws of physics made the very concept of God self-contradictory at the level of the universe's origin. But we are getting ahead of ourselves. Let us go back to basics, because to truly appreciate Hawking's argument, we need to build the foundation carefully. The universe, as best as modern science can determine, began approximately 13.8 billion years ago in an event we call the Big Bang. Before we even discuss what happened at the Big Bang, we should acknowledge what an extraordinary claim this is. 13.8 billion years. Numbers on that scale are genuinely difficult for the human mind to process. If you were to count to 1 billion at one number per second, without stopping, without sleeping, without pausing for a single moment, it would take you over 31 years. To count to 13.8 billion would take over 430 years. That is roughly how old the universe is, measured in seconds of counting. The sheer antiquity of existence is almost incomprehensible, and yet science has arrived at this number through multiple independent lines of evidence that all converge on the same answer. Now, if the universe began, If it had a starting point, then two questions immediately arise. The first is, what was there before the beginning? And the second is, what caused the beginning? These are the questions that have driven both theologians and physicists to the edges of what human understanding can reach. And it is in attempting to answer these questions that Hawking made his most profound and controversial arguments. To understand those arguments, we first need to understand what the universe is actually made of. And here, Hawking draws on one of the most celebrated insights in the history of physics, the extraordinary equation produced by Albert Einstein at the beginning of the 20th century. Einstein recognized something that had never been clearly seen before. He recognized that matter and energy are not fundamentally different things. They are two expressions of the same underlying reality, capable of being converted from one form into the other. The equation that captures this insight is almost embarrassingly simple in its appearance, E equals mc squared, and yet its implications are so vast that the world is still working through them more than a century after. Einstein first wrote it down. What it says, at its most basic level, is this: matter is concentrated energy. Energy is liberated matter. The two are interchangeable, related by the speed of light squared, which is an enormous number, which is why a very small amount of matter can release a tremendous amount of energy, as the terrifying events of the 20th century demonstrated. So matter and energy are the same thing. This means that if we are cataloging what the universe is made of, we can reduce the list. Instead of needing matter and energy as two separate ingredients, we need only one, energy in various forms. But we still need a place for that energy to exist. We still need space. And space, it turns out, is not nothing. Space is not simply the absence of things. Space has properties. Space can curve and warp and expand and contract. Einstein's general theory of relativity demonstrated this with overwhelming mathematical precision, and it has been confirmed experimentally in ways that continue to this day. So the universe, in its most reduced form, appears to require two ingredients: energy and space. Now the question becomes even more pointed. Where did the energy and the space come from? This is where the Big Bang enters the picture. The evidence for the Big Bang is not speculative. It is not a guess. It is the conclusion drawn from multiple independent streams of evidence that all point in the same direction. We see it in the expansion of the universe, the fact that distant galaxies are moving away from us, and the farther away they are, the faster they appear to be receding. If we mentally run this expansion backward, like rewinding a film, everything converges on a single point at a finite time in the past. We see it in the cosmic microwave background radiation, a faint glow of energy that fills the entire sky, the afterglow of the tremendous heat of the early universe, predicted mathematically before it was discovered, and then found exactly where and as the equations said it would be. We see it in the relative abundances of the lightest elements in the universe, hydrogen and helium and lithium, which match with extraordinary precision the ratios predicted by the physics of the Big Bang. The evidence is overwhelming. The universe began. At the moment of its beginning, the entire cosmos, all the space that exists, all the energy that would eventually become every star and planet and human being and thought was compressed into a state of almost unimaginable density, and then it began to expand, not into some pre-existing space outside of it, but expansion of space itself, the very fabric of reality stretching outward in all directions simultaneously. That expansion continues to this day and is, in fact, accelerating. Now here is where things become philosophically interesting. And here is where Hawking's argument about God begins to take its most distinctive shape. One of the things that the Big Bang model implies, and this is not obvious, but it follows from Einstein's equations of general relativity, is that time itself is part of the universe. Time is not a pre-existing container into which the universe was poured. Time is a property of the universe, interwoven with space into what Einstein called space-time. And if time is part of the universe, then time began when the universe began. Before the Big Bang, there was no before. The concept of a moment prior to the Big Bang is not just unknown, it is, in the mathematical framework of general relativity, meaningless. Asking what happened before the Big Bang is a bit like asking what is south of the South Pole. The question sounds grammatically sensible, but it refers to something that does not and cannot exist within the framework we are using. This is a deeply strange idea, and it is worth sitting with it for a moment. We are so accustomed to thinking of time as a backdrop, an eternal stage on which events play out, that imagining time as something that began, as something that came into existence, requires a genuine rearrangement of our intuitions. But mathematics does not care about our intuitions, and the mathematics of general relativity is brutally consistent on this point. Now, why does this matter for the question of God? Because one of the most fundamental aspects of the traditional conception of God, certainly in the major monotheistic traditions, is that God existed before the universe. God was there in the beginning. God decided to create. God acted at a moment in time, and as a result of that action, the universe came into being. But if there was no time before the Big Bang, if the Big Bang itself was the beginning of time, then there was no moment at which God could have decided anything. There was no before in which a divine being could have existed. There was no temporal stage on which the drama of creation could have played out. Hawking found this deeply compelling. The laws of physics, he argued, do not merely make God unnecessary. They make the very concept of God as creator self-defeating, because the creative act, the moment of decision, the moment of action that started everything would have required time to exist in, and time did not exist until the universe began. God, in other words, would have had no time to create the universe, and without time, the concept of God as an actor, as a being who thinks and chooses and decides, simply dissolves into incoherence. This was not a new observation when Hawking made it, but he made it with a rigor and clarity that few others had achieved, and he embedded it within a broader scientific framework that made the argument even more powerful. Part of that framework involves what happens at the quantum level of reality, because at extremely small scales, at the scale of particles far smaller than atoms, the ordinary laws of physics that govern our everyday experience give way to a completely different and deeply counterintuitive set of rules, called quantum mechanics. And quantum mechanics has something very strange and important to say about the nature of nothing. In the quantum world, what we call a vacuum, what we think of as empty space, containing nothing, is not actually empty. It is instead a seething ocean of activity, in which particles constantly flicker into existence and then vanish again, appearing seemingly from nowhere and disappearing back into nowhere, violating what our ordinary intuitions tell us about conservation and stability. These are called virtual particles, and they are not theoretical abstractions. They have measurable effects that have been confirmed in laboratory experiments with extraordinary precision. The Casimir effect, for instance, is a phenomenon in which two parallel metal plates placed extremely close together are pushed toward each other by the pressure of virtual particles in the vacuum between them. This effect has been measured and confirmed, and it would not exist if the vacuum were truly empty. What this tells us is that at the quantum level, the boundary between something and nothing is not a hard wall, but a permeable membrane. Things can arise from what appears to be nothing, not through some arbitrary miracle, but through the operation of quantum laws that govern the behavior of reality at its most fundamental level. In the quantum world, nothing is unstable. Nothing tends to become something, spontaneously, without any external push or divine intervention. Hawking used this insight to suggest that the universe itself could have originated in exactly this way as a quantum fluctuation, a spontaneous emergence from a state of pure quantum nothingness, governed by the laws of quantum physics rather than by the hand of any creator. The universe, in this picture, did not need to be created. It needed only to be allowed, and what allowed it was not God, but physics. Now, this argument is not without its own philosophical complications, which we will address in due course. For the moment, let us stay with Hawking's framework and explore it as fully as we can. To understand the quantum origin of the universe, we need to understand something about the energy balance of existence. And here, Hawking introduces one of the most elegant and surprising ideas in modern cosmology, the concept of negative energy. We are accustomed to thinking of energy as inherently positive. Energy is what allows things to happen. Energy powers movement and light and heat and thought. But physics recognizes another form of energy, energy that has a negative value, and its existence is not a theoretical quirk, but a mathematical necessity that has real consequences for how we understand the universe. Think of it this way. Imagine a man standing on a flat piece of ground who decides he wants to build a mound of earth. He does not need to import soil from somewhere else. He simply digs into the ground beside the mound he is creating, and he piles that excavated earth on top of the mound. As the mound rises above the surface level, the pit beside it deepens below the surface level. The mound and the pit are created simultaneously, as aspects of a single process. And here is the key insight. The mound and the pit are equal and opposite. The volume of earth above the original surface level in the mound is exactly equal to the volume of empty space below the original surface level in the pit. Together, the mound and the pit sum to zero. The total change in the landscape is nothing. Something was created from nothing by redistributing what was already there, or rather, by simultaneously creating a positive and a negative that cancel each other out. Hawking argues that the universe works exactly this way. All the matter and energy we see, every star, every planet, every particle of dust floating in the vast darkness of space, constitutes the positive energy of the universe. But accompanying this positive energy, hidden in the fabric of space itself, is an equal amount of negative energy. The two cancel each other out perfectly. The total energy content of the universe is zero. And if the total is zero, then the universe can come into existence without violating any conservation law, because creating a universe from nothing is perfectly consistent with the mathematical requirement that energy be conserved. As long as the positive and negative energies are equal and opposite. This is not a poetic metaphor. This is a genuine mathematical claim about the structure of the universe, and it is consistent with what cosmologists observe when they measure the energy content of the cosmos. The positive energy of matter is counterbalanced by the negative energy associated with gravity, and when cosmologists calculate the total, the numbers come out remarkably close to zero. The universe is not a free lunch in the sense of getting something for nothing. It is, in a very precise sense, a zero-sum game in which the something and the nothing are balanced so perfectly that the whole enterprise is, energetically speaking, equivalent to nothing at all. If this is true, if the universe has zero total energy, then it becomes much easier to understand how it could have arisen spontaneously. A quantum fluctuation that produces zero net energy is not producing anything from nothing. It is, in a sense, rearranging nothing into a positive half and a negative half, a mound and a pit, a universe and its gravitational shadow. And that kind of rearrangement requires no external energy input, no creator, no divine hand. It requires only the laws of quantum physics operating in the pre-existing quantum foam of whatever existed at the most fundamental level of reality before the universe as we know it came into being. But wait, if there was a quantum foam, if there was a pre-existing something from which the universe emerged, does that push the problem back a step? Does the question simply become, where did the quantum foam come from? And who made the laws of quantum physics that governed its behavior? These are exactly the right questions to ask, and they are questions that honest scientists, including those sympathetic to Hawking's view, acknowledge as not yet fully answered. Hawking himself was aware of this. He was not arguing that science has solved the mystery of existence completely. He was arguing that the mystery has been pushed back to a point where God is no longer required as an explanation for the universe we observe, and where the scientific framework makes better sense of what we see than any theological framework does. Whether there is some deeper level of explanation for why the laws of physics themselves exist, that is a question that may be beyond the reach of any human understanding, scientific or theological. But let us stay with Hawking for a moment longer, because there is another dimension to his argument that we have not yet fully explored. And this dimension involves one of the most mind-bending objects in the known universe, the black hole. Hawking spent much of his career studying black holes. These are regions of space where the gravitational field is so intense that nothing, not even light, can escape once it has passed a certain boundary called the event horizon. Black holes form when massive stars collapse under their own gravity at the end of their lives, and they range in size from objects a few times more massive than our Sun to the supermassive monsters that sit at the centers of galaxies, containing billions of solar masses in a region of space that might be no larger than our solar system. What black holes do to spacetime is extraordinary. Einstein's equations of general relativity predict that massive objects curve spacetime, and the more massive the object, the more intense the curvature. A black hole curves spacetime so severely that at its very center, the point called the singularity, the curvature becomes infinite. The equations break down. The laws of physics as we know them cannot describe what happens at the singularity, because the singularity is a point where spacetime itself, in a sense, ends. And here is the profound connection to the origin of the universe, because the Big Bang, in the equations of general relativity, was also a singularity. The beginning of the universe was a state of infinite density and infinite curvature, a point where spacetime had its beginning, where the equations of physics as we know them once again break down. And just as the singularity inside a black hole is a point where time, in a meaningful sense, ceases to exist as a normal dimension of spacetime, the singularity of the Big Bang was a point where time did not yet exist in the form we know it. To make this vivid, consider a thought experiment. Imagine sending a perfectly accurate clock into a black hole. As the clock falls toward the event horizon, it ticks normally from its own perspective. But from the perspective of a distant observer watching the clock from a safe distance, the clock appears to slow down. The closer it gets to the event horizon, the more dramatically its ticking slows. At the event horizon itself, from the distant observer's perspective, the clock appears to freeze entirely, a consequence of the extreme time dilation caused by the intense gravitational field. And if the clock were somehow able to survive the journey to the singularity at the center of the black hole, the ticking would not merely slow, it would reach a condition where the very concept of ticking loses its meaning, because time itself ceases to behave as a dimension in the way we understand it. The conditions at the Big Bang singularity were analogous. Time at the Big Bang was not slowed or frozen. It was a dimension that had not yet taken on the form it has in our current universe. The question of what existed before the Big Bang singularity is therefore, in this framework, not merely unanswered but grammatically confused. It is asking about a time that did not exist, a before that had no content, a moment that could not have occurred because moments require time to occur in. Hawking summarized this argument with characteristic directness. God would have had no time in which to create the Big Bang. There is no temporal framework within which a divine act of creation could have been located. Therefore, the search for a creator operating in time before the universe began is a search for something that the structure of reality itself makes impossible. This is the core of Hawking's theological conclusion. It is not an emotional argument. It is not a cultural argument. It is not even, strictly speaking, an argument about the existence or non-existence of some divine being in the abstract. It is a very specific argument about a very specific claim, the claim that a creator existed in time before the universe and brought the universe into being through a deliberate act. That specific claim, Hawking argues, is incompatible with what we know about the nature of time and the origin of the universe. Now, it is important to understand what Hawking's argument does not say, because it is easy to misread it as a broader and more sweeping claim than it actually is. Hawking was not saying that there is nothing beyond the universe. He was not saying that consciousness is purely physical. He was not saying that the experience of meaning, of beauty, of love, of moral obligation, all the things that give human life its texture and depth are illusions. He was making a much more specific argument, that the laws of physics, as we understand them, do not require a divine creator to explain why the universe exists and why it has the properties it has, and that the specific theological conception of God as a being who existed before the universe and created it in time is, on purely physical grounds, incoherent. This is a position that many people find deeply disturbing, and the reasons for their disturbance are worth taking seriously, because science, for all its extraordinary power, does not cover all of human experience. It does not answer every question that matters. And dismissing the human need for meaning and connection and transcendence as mere confusion is itself a kind of intellectual overreach that Hawking, to his credit, largely avoided. But let us now turn our attention to the other side of this conversation. Because even accepting Hawking's framework entirely, even granting every one of his arguments their full force, there remain questions that science has not answered and may not be able to answer. And these questions are not trivial. They are not the last gasps of a defeated theology desperately grasping for any remaining gap in scientific knowledge. They are genuine, profound puzzles that sit at the very boundary of what human understanding can reach. The first, and perhaps the most fundamental of these questions, is deceptively simple. The universe is expanding. We know this, we can observe it directly. But what is it expanding into? This is not a question that most scientists spend much time on, because in the framework of general relativity, the question itself rests on a misunderstanding. The universe is not expanding into pre-existing space the way a balloon expands into the air around it. The universe is space, and when we say the universe is expanding, we mean that the fabric of space-time itself is stretching, that the distances between distant objects are growing not because those objects are moving through a pre-existing space, but because the space between them is increasing. There is, in this framework, nothing outside the universe for it to expand into. The universe is not a thing inside a larger container. It is the container itself, expanding. But here's the problem with this answer. It is deeply unsatisfying to many people, and not just because it is counterintuitive. It is unsatisfying because it raises a further question. If the universe is all there is, if there is nothing outside it, then what exactly is the boundary of the universe like? When we say there is nothing outside, what do we mean by nothing? Is it a mathematical nothing, an absence of any structure whatsoever? Is it something stranger, a realm where the usual rules do not apply? And if there truly is nothing outside the universe, then in what sense did the universe come from nothing? Because if there was genuinely nothing, no quantum foam, no laws of physics, no space-time, no mathematical structures, no possibility space of any kind, then how did anything emerge from it? Can quantum mechanics operate in a context where there is truly nothing, including no quantum laws? This is where Hawking's argument encounters its deepest philosophical challenge, because the laws of quantum physics are themselves something. They are not nothing. They represent a structure, a set of constraints on how reality behaves, a framework within which the universe's emergence can be understood. But these laws are part of the universe. They describe the universe, and if the universe came from quantum fluctuations, then the quantum laws must have existed for those fluctuations to occur. Which means the quantum laws are not themselves explained by the emergence of the universe. They pre-existed it in some sense. And the question of where they came from, of why the quantum laws have the specific form they do rather than some other form, is a question that science has not answered. This is not merely a gap that future science will inevitably close. It may be a question that lies beyond the reach of any scientific methodology, because science works by observing what exists and formulating laws that describe those observations. But the laws themselves, the meta-level structure that makes the universe the kind of place where observation and formulation are possible, science cannot observe or formulate, because they are the precondition for the activity of science rather than its subject matter. This is a philosophical point, not a scientific one, and it is a point that deserves to be taken seriously rather than dismissed. A second profound question concerns the expansion of the universe itself. We said that the universe is expanding, but recent observations have revealed something even more surprising. The expansion is accelerating. Distant galaxies are not just moving away from us, they are moving away from us faster and faster, as if some invisible force were pushing them apart with increasing urgency. This accelerating expansion is attributed to what cosmologists call dark energy, a mysterious form of energy that permeates all of space and has a repulsive gravitational effect, pushing the fabric of space-time apart rather than pulling it together. But here is the problem. Dark energy is not merely a name for something we understand. It is a label for something we observe but cannot explain. We know dark energy is there because of its effects. We can measure those effects with extraordinary precision. But we have absolutely no idea what dark energy actually is, where it comes from, why it has the specific magnitude it does, or what its ultimate fate will be. It accounts for approximately 68% of the total energy content of the universe, making it by far the dominant component of the cosmos, and we cannot explain it. This is not a minor gap in scientific knowledge. This is one of the most significant unsolved problems in all of physics. And alongside dark energy, there is dark matter, another mysterious substance that we cannot see or detect directly, but whose gravitational effects are unmistakable. Dark matter holds galaxies together, shapes the large-scale structure of the universe, and yet we have no idea what it is made of. It is not made of atoms. It is not made of any of the particles we have identified in our models of particle physics. It is something else entirely, something we have not yet discovered, accounting for roughly 27% of the total energy content of the universe. Together, dark energy and dark matter account for approximately 95% of the universe, leaving only about 5% the atoms and particles we actually understand as the familiar terrain of ordinary physics. We know almost nothing about most of the universe, and this is not cause for despair, it is cause for wonder. It is a reminder that the universe is vastly larger and stranger and more complex than our current understanding can encompass. But it is also a reminder that intellectual humility is warranted. A scientist who claims, on the basis of current knowledge, to have definitively resolved the question of God's existence is making a claim that goes well beyond what the evidence actually supports. Hawking was generally careful to avoid that kind of overclaiming, though his rhetoric was sometimes more absolute than his actual arguments warranted. What he did argue, and what the evidence does support, is that within the framework of physics as we know it, the universe does not appear to require a divine creator to explain its origin or its operation. That is a significant claim. It is not the same as proving that no divine being exists. It is the narrower but still important claim that science does not need God as a hypothesis, that the universe makes sense, or at least as much sense as it currently makes, without invoking any supernatural agency. Whether that narrower claim is the most interesting or the most important thing one can say about the relationship between science and God is itself a deeply contested question. Because the question of God is not purely a scientific question, It never has been. The question of God touches on dimensions of human experience that science, by its own methodology, is not designed to address. Science is a magnificent tool for understanding how the universe works, how particles interact, how stars form, how life evolves, how diseases spread and can be cured. But science is not designed to answer questions about why the universe exists rather than not existing, or what the existence of the universe means, or whether the order and beauty we find in nature point towards something beyond nature itself. These are philosophical and theological questions, and dismissing them as simply confused or unanswerable is itself a philosophical position, not a scientific conclusion. This is something that Hawking's close friend and colleague John Lennox, the mathematician and philosopher of science at Oxford University, has pointed out repeatedly and with considerable force. Lennox argues that science and belief in God are not inherently in conflict, that they are answers to different kinds of questions, addressing different levels of reality. He uses a simple but illuminating analogy. If you ask why a kettle is boiling, you can give two perfectly correct and complementary answers. You can say the kettle is boiling because the heat from the stove is causing the water molecules to move faster and faster until they have enough energy to escape into the gas phase. That is the scientific answer. But you can also say the kettle is boiling because I want a cup of tea. That is the intentional answer, the answer in terms of purpose and desire and meaning. Neither answer contradicts the other. Neither makes the other unnecessary. They operate on different levels of description, and both levels are real. Lennox argues that this is exactly the relationship between science and theology. Science tells us how the universe works, what the mechanisms are, what the laws are, how the processes unfold. Theology, at its best, attempts to address why the universe exists, what it means that it exists, and what our relationship to its existence is. These are complementary questions, not competing ones. And a person who answers both, drawing on both scientific understanding and theological insight, is not being intellectually inconsistent. They are being appropriately attentive to the full range of questions that the universe and human existence present to us. Now, Hawking would almost certainly have pushed back on this framing. He would have argued that the theological level of description adds nothing explanatory that is not already present in the scientific level. He would have said that once you have explained how the universe works, once you have traced the causal chain back as far as physics allows, and shown that the universe can arise naturally from quantum processes without any divine intervention, there is no remaining explanatory work for God to do. The theological level is not complementary to the scientific level. It is simply redundant. It is a story we tell ourselves because we find it comforting, but it does not add any information about how reality actually functions. This is the crux of one of the deepest and most unresolved debates in the philosophy of science and the philosophy of religion. And it is a debate in which extremely intelligent and extremely thoughtful people have taken both sides without either side definitively prevailing. The history of this debate is not a story of science steadily winning against religion, any more than it is a story of religion holding its ground against the encroachments of science. It is a story of two very different modes of human understanding, each with its own strengths and limitations, each addressing questions that the other cannot fully reach, and each illuminating aspects of reality that the other, operating alone, would leave in darkness. What is particularly interesting about this debate in the context of Hawking's arguments is the way that some of the most serious contemporary thinkers about the nature of physical reality have found themselves drawn towards something that sounds, if not quite like traditional religious belief, then at least like a recognition that the universe is stranger and more philosophically loaded than a purely materialistic account can capture. Consider the question of the fine-tuning of the universe. This is one of the most discussed and most contentious topics at the intersection of physics and theology, and it is worth spending some time with it because it represents a genuine scientific puzzle that has profound philosophical implications. When physicists examine the fundamental constants of nature, the numbers that define the strength of the four fundamental forces, the masses of the elementary particles, the rate of expansion of the universe, and so on, they find something deeply puzzling. These numbers appear to be extraordinarily precisely calibrated to permit the existence of complexity. If the gravitational constant were even slightly different, not drastically different, but slightly different, the universe would either collapse back on itself before stars had time to form, or expand so rapidly that matter could never clump together into galaxies and stars in the first place. If the strong nuclear force, which holds atomic nuclei together, were slightly weaker, atoms heavier than hydrogen could not exist, and the rich chemistry that makes life possible would be impossible. If the cosmological constant, the number associated with dark energy, were even slightly larger, the universe would have blown apart before any structure could form. The numbers that define the universe appear to be set within extraordinarily narrow ranges that permit the existence of chemistry, planets, stars, and ultimately life. And the question that this observation raises is, why? Why are the constants of nature precisely the values they need to be for complexity to exist? Is this a coincidence? Is it the result of some deeper physical principle we have not yet discovered? Is it the consequence of there being a vast multitude of universes, each with different constants, with our universe being simply the one that happened to have the right values by chance? Or is it, as many theologians and some scientists have suggested, evidence of design of a universe crafted with the specific intention of being hospitable to life and to minds capable of understanding it? Hawking himself took the multiverse approach. He argued, and contributed to the mathematical framework for arguing, that there is not just one universe, but an enormous, possibly infinite number of universes, each with different physical laws and constants, arising from a landscape of possibilities that quantum physics and string theory make available. In this picture, there is nothing surprising about our universe having the constants it does. With enough universes, some will inevitably have the right values by chance, just as with enough lottery tickets, someone will inevitably win. We happen to be in one of the universes where the constants permit our existence, and the reason we observe those constants rather than others is simply that we could only have arisen in a universe that permitted us to arise. This is what philosophers call the anthropic principle. It is a logically coherent argument, but it is also, in an important sense, deeply unsatisfying, and not merely because it is emotionally uncongenial. It is scientifically unsatisfying because the multiverse, as Hawking and others describe it, is not directly observable. We cannot see other universes. We cannot measure their constants. We cannot test the multiverse hypothesis in the way we can test a hypothesis about the properties of a particle or the behavior of a gas. The multiverse is a theoretical construct, inferred from the mathematics of certain models, but not directly confirmed by observation. This does not make it wrong. Much of the best physics involves entities and processes that are not directly observable, but it does mean that using the multiverse to explain away the fine-tuning problem is not quite as scientifically definitive as Hawking's confident tone sometimes implied. And this is where the debate gets genuinely interesting. Because a theologian who says that the fine-tuning of the universe's constants is evidence of a divine intelligence is making a claim that is, in an important sense, no less empirically grounded than the physicist who says the fine-tuning is explained by the multiverse. Both claims go beyond what direct observation can confirm. Both require accepting theoretical constructs whose existence is inferred rather than observed. And both rest ultimately on a kind of philosophical intuition about what kind of explanation is most satisfying and most likely to be true. This does not mean the two claims are equally well supported. The multiverse hypothesis arises naturally from mathematical frameworks, string theory, eternal inflation that have genuine predictive power and are motivated by considerations well within the domain of physics. The theological hypothesis requires introducing an entity, a divine mind, whose nature and properties are not specified by any physical theory, and whose existence raises at least as many questions as it answers. Where did God come from? What is the nature of divine consciousness? How does divine intention translate into physical law? These are not trivial questions, and theologians have spent millennia wrestling with them without arriving at universally accepted answers. But the point is that neither hypothesis is so clearly superior to the other that the debate can be considered closed. And anyone who tells you that science has definitively answered the question of God in either direction is overstating what the evidence actually shows. With all of this in mind, let us return to the specific character of Stephen Hawking's argument and try to assess it fairly. What did Hawking actually establish, and what questions does his framework leave open? What Hawking established, with genuine brilliance and intellectual rigor, is that the universe as we observe it is consistent with having arisen naturally, without divine intervention, through processes governed by the laws of physics. He showed that the Big Bang is consistent with the laws of thermodynamics, with quantum mechanics, and with general relativity. He showed that the universe having zero total energy makes its spontaneous origin from a state of zero energy mathematically sensible rather than miraculous. He argued, with great force and clarity, that the absence of time before the Big Bang removes the temporal framework within which a divine act of creation would have to occur, making the traditional conception of God as creator philosophically incoherent. These are genuine intellectual achievements. They are not the complete refutation of every possible conception of God, but they are serious arguments against a particular and widely held conception of God, the conception of God as a being who existed before the universe in time, who deliberated about whether to create, and who then acted in time to bring the universe into existence. That specific conception is, in Hawking's framework, deeply problematic, and the problems are not merely theological, but physical. What Hawking did not establish, and what cannot honestly be said to follow from his arguments, is that the universe has no meaning, that consciousness is reducible to physics, that the experience of moral obligation is an illusion, that beauty and love and grief and hope are nothing more than particular configurations of atoms following the laws of nature, or that no being of any kind, however different from traditional conceptions of God, played any role in shaping the universe we inhabit. These broader claims, which are sometimes made in Hawking's name or in the name of science more generally, go well beyond what the physics actually implies. They are philosophical positions dressed up as scientific conclusions, and they deserve to be recognized as such. The philosopher Thomas Nagel himself, an atheist, has argued in his book On the Nature of Mind and the Cosmos that the standard materialist account of the universe, the account that says everything that exists is ultimately physical matter following physical laws, faces profound difficulties when it tries to account for consciousness, for reason, for the capacity for abstract mathematical thought. Nagel does not argue for God, but he argues, compellingly, that the universe as described by modern physics is not obviously the kind of universe that would give rise to conscious beings capable of understanding it. The existence of mind, he suggests, is a datum that any adequate account of reality must take seriously, and a purely materialist account, the kind of account that Hawking's framework implies, has not yet come close to explaining it. This is not a trivial point. The most remarkable fact about the universe, in many ways, is not that it exists, or that it has the constants it does, or that it has a history of 13.8 billion years. The most remarkable fact is that it has produced, in the thin outer layer of a small planet orbiting an ordinary star in the outer suburbs of one of hundreds of billions of galaxies, creatures who can look out at the universe and understand it, creatures who can formulate the laws of physics, trace the history of the cosmos, calculate the trajectories of spacecraft, and ask questions about the origin and meaning of everything. The existence of minds capable of comprehending the universe is, in a very real sense, the most extraordinary fact there is. And any account of the universe that does not take that fact seriously, that treats consciousness as an afterthought, a lucky accident, an epiphenomenon of no deeper significance, is leaving out what may be the most important thing. Hawking was aware of this. He wrote, in one of his most celebrated passages, that we are just an advanced breed of monkeys on a minor planet of a very average star. But then he added, but we can understand the universe. That makes us something very special. That addendum, the recognition that understanding is itself remarkable, is a crack in the purely deflationary account of human existence that Hawking's atheism might otherwise seem to imply. He seemed to sense, even within his rigorously scientific framework, that the capacity for understanding was something more than merely physical, even if he was not prepared to draw explicitly theological conclusions from that recognition. Now let us think about what the question of God actually means for most people who believe in it. Because the theological arguments made by professional philosophers and scientists on both sides are not the primary reason that most human beings believe in God. Most people who believe in God do not believe because they have read the cosmological argument of Aquinas, or the ontological argument of Anselm, or the teleological argument of Paley, and found them convincing. They believe because of something more immediate, more personal, more existential. They believe because of experience, the experience of meaning, of connection, of something felt in moments of profound joy or devastating grief that seems to exceed what the purely physical account of those moments can capture. They believe because of community, because of tradition, because of the stories and rituals and practices that have shaped their sense of self and their understanding of the world from their earliest years. They believe, in many cases, because belief gives them a framework for living that provides orientation and purpose and moral clarity that they do not know how to find elsewhere. And here, even Hawking, in one of his more candid and less combative moments, acknowledged something important. He said that even if God is not required for the creation of the universe, the human mind may require something like God. Not because God is literally real, in Hawking's view, but because the psychological and social functions that belief in God serves are genuine functions, addressing genuine human needs that cannot simply be dismissed as superstition. There is something deeply honest in this acknowledgement, because the truth is that human beings are not purely rational creatures who form beliefs on the basis of evidence alone and abandon those beliefs the moment the evidence runs against them. Human beings are emotional and social and meaning-seeking creatures, and the beliefs that sustain us through the hardest moments of our lives are not always the beliefs that can be most rigorously justified by evidence. When someone is sitting in a hospital waiting room at 3 in the morning, waiting to hear whether their child is going to survive, the question of whether the Big Bang required a prior causal agent is not the question that matters. The question that matters is whether there is something beyond the cold machinery of physics that hears the desperate prayer that is forming in the waiting person's heart. And that question cannot be answered by physics because it is not a physics question. It is a question about the ultimate nature of reality, about whether the universe is, at its deepest level, meaningful or meaningless, personal or impersonal, indifferent or attentive. Science cannot answer that question. Not because science is inadequate, science is magnificent at what it does, but because the question is not the kind of question that science is designed to answer. Science tells us what the universe is made of and how it behaves. It does not tell us whether the universe cares. And the question of whether the universe cares in some sense, at some level, through some mechanism that we do not yet understand, is the question that religion has always been about. Now, some scientists would say that the very idea that the universe could care is nonsensical, that caring is something that brains do, and that attributing it to the universe itself is a category error, a confusion of the kind of thing the universe is with the kind of thing that minds are. And this may be right, but it is a philosophical claim, not a scientific one, and it is a claim that should be held with appropriate humility, given how little we actually understand about the nature of consciousness and its relationship to the physical world. The philosopher David Chalmers has articulated what he calls the hard problem of consciousness, the problem of explaining why physical processes in the brain give rise to subjective experience at all. Why is it that when certain neurons fire in certain patterns, there is something it is like to see red, or to feel pain, or to hear music? Why is the physical process accompanied by any inner experience at all, rather than just happening in the dark, functionally effective but utterly without any subjective dimension? This question has not been answered. It is not close to being answered. Some scientists believe it will eventually be answered by a more complete neuroscience. Others, including some very distinguished philosophers and scientists, believe it represents a fundamental gap in the materialist framework, a phenomenon that matter following the laws of physics is, in principle, insufficient to explain. If consciousness is genuinely not reducible to physics, if the inner life of a human being cannot be fully explained in terms of particles and forces, then the universe is more than physics describes. And if the universe is more than physics describes, then the confident claim that physics has shown God to be unnecessary becomes considerably less confident. Because what God has traditionally been associated with, in the philosophical traditions of most cultures, is precisely this: a dimension of reality that transcends the physical, that is not captured by the equations of matter and force, but that is nonetheless real and present, and in some sense the ground of everything else. We are not arguing here that consciousness proves God. That is a much longer and more complex argument than we have space for, and it is an argument that honest philosophers acknowledge has serious problems as well as serious insights. What we are arguing is that the question of God cannot be settled by physics alone, because physics, for all its extraordinary power, does not yet account for everything that exists. And the things it does not yet account for consciousness, meaning beauty, moral obligation, are not peripheral to human experience. They are central to it. They are, in many ways, the most important things about being human. And any account of the universe that treats them as epiphenomenal noise to be explained away rather than fundamental phenomena to be taken seriously is not giving a complete picture of reality. With all of this as background, let us return to the remarkable figure of Stephen Hawking himself and think about what his life and his work actually reveal about the human relationship to the universe. Hawking was diagnosed with motor neuron disease, a progressive and ultimately fatal condition, when he was 21 years old. He was given 2 years to live. He lived for another 55 years, producing some of the most important theoretical physics of the 20th and 21st centuries. The contrast between what his body could do and what his mind could do became more extreme with every passing year, until in his final decades he was completely paralyzed, communicating through a computer that interpreted the tiny movements of a single cheek muscle, producing speech from that extraordinary and still ferociously active mind through a machine that became his voice. There is something almost mythological about this image. A man stripped of almost every physical capacity, reduced to a single functioning muscle, and yet exploring the farthest reaches of the cosmos with a precision and depth of understanding that few human minds in all of history have equaled. If ever there was a human life that seemed to embody the idea that mind transcends matter, that consciousness is something over and above the physical substrate it happens to inhabit, it was Stephen Hawking's life. The irony, of course, is that Hawking himself would have rejected this interpretation entirely. He believed consciousness was produced by the brain, and that when the brain died, consciousness ceased. He found no comfort in the idea of an afterlife and had no patience for what he regarded as wishful thinking. But the image of him remains the frail, motionless body, the eyes still alive with intelligence and wit, the voice speaking slowly through the machine, and it is hard not to feel, looking at that image, that something about it exceeds what the purely physical account can fully capture. This is not an argument. It is a response, an aesthetic and emotional response to a life of extraordinary particularity. But aesthetic and emotional responses are not nothing. They are, in fact, part of the data, not the data of physics, but the data of human experience, and any complete account of reality must find a place for them. Hawking's closest intellectual companions wrestled with these questions alongside him, and not all of them arrived at the same destination. Roger Penrose, who collaborated with Hawking on some of the most important work of their careers, and who shared the Nobel Prize in Physics in 2020 for work related to black holes and the singularities they contain, has been considerably more open than Hawking to the possibility that consciousness is not reducible to computation, not fully explicable by the known laws of physics, and may involve something he associates it tentatively with quantum processes in the brain that our current understanding of the physical world does not capture. Penrose is not a theist in any traditional sense, but his willingness to recognize the limits of the materialist framework and to take seriously the possibility that consciousness represents a genuine anomaly within that framework demonstrates that even among the most rigorous and sophisticated scientific thinkers, the question of what the universe is ultimately made of and what role mind plays in that ultimate makeup is very much open. And then there is the question of the extraordinary mathematical structure of the universe itself. The physicist Eugene Wigner wrote a celebrated essay about what he called the unreasonable effectiveness of mathematics, the fact that the abstract mathematical structures developed by pure mathematicians, often with no practical application in mind, turn out, decades or centuries later, to describe with uncanny precision the deep structure of physical reality. Complex numbers, developed as a mathematical curiosity, turn out to be essential for quantum mechanics. Non-Euclidean geometry, developed as a purely abstract exploration of what geometry would look like if you relax certain axioms, turns out to be exactly the geometry of spacetime as described by general relativity. Group theory, developed by mathematicians studying the abstract properties of symmetry, turns out to describe with extraordinary precision the properties of elementary particles. Why should this be? Why should the universe be mathematical? Why should abstract structures created in the minds of mathematicians, following the internal logic of mathematics with no reference to physical reality, turn out to be the language in which physical reality is written? This is a genuine puzzle, and it is one that has led some very distinguished physicists and mathematicians to the edge of something that sounds, if not quite like religious faith, then at least like a profound sense that the universe is not merely physical stuff obeying arbitrary rules, but something more structured, more elegant, more deeply ordered than the purely materialist picture suggests. Max Tegmark at MIT has proposed the mathematical universe hypothesis, the idea that the universe is not merely described by mathematics, but actually is a mathematical structure. Other universes, in this view, are not physical but mathematical, and our universe is simply the mathematical structure that we happen to inhabit. This is a striking and in some ways beautiful idea, and it has the interesting implication that the laws of mathematics are not merely tools we use to describe reality, but our reality itself, at the most fundamental level. And if reality is ultimately mathematical, if the deepest stratum of existence is structure, pattern, relation, and order, then the ancient intuition that the universe is, at its core, intelligible, rational, and shaped by something that has more in common with mind than with matter becomes considerably less obviously wrong. None of this proves God. It does not even make God particularly likely in any conventional probabilistic sense. But it does suggest that the universe, the more deeply you look at it, is a stranger and more philosophically loaded place than the confident dismissals of religion that sometimes issue from the scientific community imply. And a strangeness and philosophical depth of that magnitude should inspire something other than the comfortable certainty that all the questions are settled and all the answers point in the same direction. Let us now turn to the specific ways in which human beings have historically made sense of the relationship between the scientific and the theological, because the history of this relationship is considerably more complex and more interesting than the popular narrative of inevitable conflict suggests. The popular narrative goes something like this. Once upon a time, people were ignorant and afraid, and they invented God to explain what they could not understand and to comfort themselves in the face of death and suffering. Then came science, which provided real explanations for the phenomena that religion had wrongly attributed to divine action. And as science advanced, the domain of the divine was progressively reduced, pushed back from control of weather and disease and celestial mechanics, until all that remained for God to do was to have started the Big Bang. And now, even that last refuge has been challenged by Hawking and his colleagues. The end point of this narrative, clearly, is the complete elimination of God as a meaningful concept, replaced entirely by a scientific account of reality that leaves no gaps for divine action. This narrative is not accurate, and it is worth taking the time to understand why, because the inaccuracy matters for how we think about the current state of the debate. The relationship between science and religion is not and has never been a simple story of conflict. It is a story of complex and shifting relationships, with periods of genuine tension, but also long periods of fruitful collaboration and mutual support. Many of the founders of modern science were deeply religious, not despite their science, but often because of it. Johannes Kepler, who formulated the laws of planetary motion, saw his work as a way of reading the mind of God as expressed in the mathematical structure of the heavens. Isaac Newton, who invented calculus and formulated the laws of motion and gravitation, wrote more theology than physics and believed deeply that his scientific work was revealing the rational order that God had built into creation. Gregor Mendel, who discovered the laws of heredity that became the foundation of modern genetics, was an Augustinian friar who did his famous pea experiments in the garden of his monastery. Georges Lemaitre, the Belgian priest and physicist who first proposed what became known as the Big Bang theory, was a Catholic priest who saw no conflict between his faith and his cosmological work. And the list goes on. None of this proves that the religious beliefs of these scientists were correct, any more than the scientific contributions of atheist scientists prove that atheism is correct. But it does complicate the narrative that science and religion are natural enemies, that the progress of science necessarily implies the retreat of religion. The actual history is far more nuanced, and the actual logical relationship between scientific explanation and religious belief is far more complex than the popular narrative suggests. What science has done, and this is a genuine achievement that should not be minimized, is to push God out of specific explanatory roles that theological tradition had assigned to the divine. Thunder and lightning are not divine anger. Disease is not divine punishment. Evolution is not directed by divine intention. The formation of stars and planets occurs according to natural processes that operate without any need for divine supervision. In all these cases, scientific explanation has replaced theological explanation, and the theological explanations have retreated or been abandoned. But theological thinkers have not simply been passive in the face of this process. Many of them have argued, with considerable sophistication, that the replacement of theological explanations by scientific ones is not a defeat for theology, but a clarification. It is a clarification of what theology is actually about. If God is conceived as an agent who fills in the gaps in natural processes, who sends the lightning personally, who decides which seeds will germinate and which will not, who guides each evolutionary mutation, then the advance of science is indeed a progressive elimination of God. But if God is conceived not as a gap filler, but as the ground of being itself, as the reason why there is something rather than nothing, as the source of the mathematical rationality that makes the universe intelligible, as the ultimate context within which the universe and its laws exist, then the advance of science is not a threat to God, but a progressive uncovering of the magnificent rational order that divine creativity has built into. Creation. This is not a trivial distinction. It is the difference between a God who is an actor within the universe a particularly powerful agent who manipulates the laws of nature to produce desired outcomes, and a God who is the ground of the universe itself. The reason why the laws of nature exist and have the form they do, the ultimate source of the order and intelligibility and beauty that science progressively reveals, the former conception of God is indeed threatened by scientific advance. The latter conception is not threatened by science at all, and some of its defenders would argue that science actually supports it by revealing more and more clearly the depth and elegance and mathematical precision of the rational order built into the fabric of reality. Hawking's arguments, powerful as they are directed primarily at the former conception of God, at the interventionist deity who acts in time to create and to sustain and to adjust the universe. And against that conception, his arguments are genuinely compelling. But the latter conception, the more philosophically sophisticated conception of God as the ground of being, the source of rational order, the reason why there is something rather than nothing is not obviously touched by Hawking's arguments at all. Because even if the universe arose spontaneously through quantum processes, even if time did not exist before the Big Bang, even if no divine hand pushed the first particle into existence, the question of why there are quantum processes to do the arising, why there are laws of physics to govern the quantum behavior, why there is a mathematical structure to the universe at all, why anything at all exists rather than pure nothingness, these questions remain, and they are not answered by the physics of the Big Bang. Let us now think about what it actually means for a human being to live with these questions not as an academic exercise, not as a topic for philosophical debate, but as a lived reality. Because most people who think seriously about God are not engaged in a purely intellectual exercise. They are trying to figure out how to live. They are trying to understand what they owe to other people and to the world. They are trying to make sense of suffering their own and others. They are trying to find a framework of meaning that is wide enough and deep enough to support a fully human life, with all its complexity and all its pain. And here, the limitations of the purely scientific account become most apparent. Because a purely scientific account of the universe tells us nothing at all about what we should do, about what we owe to each other, about what gives a human life its worth. Science can tell us how to maximize the satisfaction of preferences, given a particular set of constraints. But it cannot tell us which preferences are worth satisfying, or why the preferences of other people should matter to us at all, or why we should sacrifice our own preferences for others, or why the suffering of a stranger on the other side of the world should have any claim on our attention and our resources. These are moral questions, and they are among the most important questions human beings face. And the answer to them that has, throughout most of human history and across most human cultures, made the most sense to most people is some version of the claim that human beings have inherent worth not because they are useful, not because they are strong or beautiful or talented, but because they are human beings, and being human carries a kind of dignity that demands to be respected. This claim, the claim of inherent human worth, is the foundation of almost every account of human rights that we have developed, and it is the moral foundation that makes possible the aspiration to a just and humane civilization. But where does inherent human worth come from? If human beings are nothing more than complex physical systems, temporarily organized in a particular pattern by the blind processes of evolution, then it is genuinely hard to see why they should be thought to have inherent worth. Value, in a purely physical universe, must be generated somehow. It cannot simply be a brute given. Physical processes do not generate value. They generate arrangements of matter and energy. The assignment of value to those arrangements is something we do, something minds do. And if minds are simply physical processes, then the values they generate are simply products of physical processes, with no claim to be more than that. This is the uncomfortable implication that runs beneath the surface of the confident scientific dismissals of religion. If there is no God, if the universe is a purely physical system with no inherent meaning or value, then the moral convictions we hold most dear, convictions about human dignity, about justice, about the wrongness of cruelty, and the rightness of compassion are, at the deepest level, not discoveries about the nature of reality, but projections of our own preferences onto a universe that is indifferent to them. This does not necessarily mean we should abandon those convictions. There are sophisticated philosophical accounts of how we can maintain robust moral commitments within a naturalistic framework, but it does mean that the question of their ultimate grounding is considerably more difficult than the confident science versus superstition narrative acknowledges. And this is one of the reasons, perhaps the most practically important reason, why the vast majority of human beings across all times and all cultures have found the concept of God not merely emotionally comforting, but intellectually compelling. Because God, in most conceptions of the divine, provides a grounding for value that pure physics cannot provide. God is the reason why things matter, not merely the reason why things exist. And the question of why things matter, why this life, this moment, this person in front of you matters, is a question that human beings cannot, in practice, avoid asking. And it is a question for which the answers science provides are, by themselves, genuinely insufficient. We have traveled a long and winding road through some of the most challenging and important territory that human thought has ever explored. We began with the simple observation that for most of human history, God served as the explanation for everything that lay beyond human understanding. We followed the story of how science, beginning with the careful observations of thinkers like Aristarchus, and culminating in the extraordinary theoretical achievements of the 20th and 21st centuries, provided natural explanations for phenomena that had previously required divine ones. We examined Stephen Hawking's powerful and rigorously argued case that the universe does not require a creator, that it can arise spontaneously from quantum processes, that the absence of time before the Big Bang removes the logical space in which a divine act of creation could occur, and that the laws of physics as we understand them are sufficient to account for everything we observe without invoking any supernatural agency. And we examined the limits of that case, the questions it leaves open, the dimensions of human experience it does not address, the philosophical puzzles it sidesteps rather than resolves. We explored the fine-tuning of the universe's constants, the mystery of consciousness, the unreasonable effectiveness of mathematics, the grounding of moral value, and the distinction between God as a gap filler within the universe and God as the ground of the universe itself. We found that the question of God, properly understood, is not a question that science has answered, or is close to answering, not because science is inadequate, but because the question, at its deepest level, is not a scientific question. It is a question about the ultimate nature of reality, about whether existence has meaning, about whether the universe is at its core a place of pure indifference, or a place that, in some sense beyond our current understanding, is oriented towards something, toward life, toward mind, toward value. Now let us bring all of this together and ask the question that matters most practically. Given everything we know, the extraordinary achievements of modern science, the genuine limits of what science can tell us, the deeply human needs that religious belief has historically served, and the real philosophical puzzles that remain unresolved at the frontier of our understanding, how should we think about God? How should we hold this question in our minds and our lives? The first thing to say is that intellectual honesty requires resisting the temptation to claim more certainty than the situation warrants. This applies on both sides of the debate. The confident atheist who insists that science has demonstrated the non-existence of God is making a claim that goes well beyond what science actually shows. Science has shown that the universe can be described, up to a point, without reference to God. It has shown that natural processes governed by natural laws can account for a vast range of phenomena that were once attributed to divine action. But it has not shown, and in principle, given the nature of what science does, cannot show that there is no God, that consciousness is fully reducible to physics, that the universe has no meaning, or that the experience of transcendence that billions of human beings across all cultures and all centuries have reported is nothing more than a neurological illusion. These are philosophical claims, not scientific ones, and they deserve to be held with appropriate philosophical humility. Equally, the confident theist who insists that science is simply wrong, that the universe was created 6,000 years ago, that evolution did not occur, that the geological and cosmological evidence is a massive mistake or deception, that person is also making claims that go well beyond what the evidence warrants, and in a direction that is directly contradicted by overwhelming empirical evidence. Whatever one believes about God, it cannot honestly be reconciled with a denial of the basic findings of modern science. The universe is 13.8 billion years old. Life on Earth evolved over billions of years through the process of natural selection. The Big Bang happened. The laws of physics are real and consistent and universal. These are not merely the opinions of scientists. They are the conclusions of an extraordinarily careful and self-correcting process of investigation that has earned its authority through its predictive success and its practical applications. So intellectual honesty requires holding both of these temptations at bay: the temptation to claim that science has answered everything, and the temptation to deny what science has clearly established. The honest position, The intellectually defensible position is something like this. Science has revealed a universe of breathtaking scale and beauty and order, operating according to laws that are mathematical in character and universal in scope, arising from origins that are deeply mysterious, and that may always remain so. Within that universe, conscious beings have appeared who can understand it, who can feel awe at it, who can ask questions about it, and who find in it both the raw material for magnificent scientific achievement and the occasion for profound philosophical and spiritual wondering. Whether that wondering, and the traditions that have grown up around it, are tracking something real about the ultimate nature of the universe, whether the intuition of meaning and transcendence and divine presence that so many human beings have experienced is a genuine cognitive contact with a deeper layer of reality, or a beautiful and useful, but ultimately misleading product of minds, evolved for other purposes, that question is not settled. It may not be settleable, and living thoughtfully with an unsettled question of that magnitude, without collapsing into either dogmatic certainty or nihilistic despair, is one of the most demanding and most important things a human being can do. Stephen Hawking himself, for all his confident public atheism, was not entirely immune to this kind of wondering. His language, when he was at his most expansive and most honest, repeatedly reached towards something that his strict commitment to materialism should not have permitted. He spoke of wanting to know the mind of God. He ended his most celebrated book, A Brief History of Time, with the observation that if we ever succeed in developing a complete theory of the universe, it would be the ultimate triumph of human reason, and we would then know the mind of God. He immediately explained that by God he meant the laws of nature, but the language he chose, the language of mind, of God, is not accidental. It reflects something genuine in his experience of doing physics at the highest level. The sense that the mathematical structure of the universe is not merely a collection of useful equations, but something with a character, an elegance, an almost intentional quality that rewards the deepest attention we can bring to it. This sense, the sense that the universe is not arbitrary, that its mathematical order is somehow fitting, that its beauty is not a projection of our aesthetic preferences, but a real property of how things are, is widely shared among physicists, even those who, like Hawking, describe themselves as atheists. Richard Feynman spoke of the pleasure of finding things out, of the aesthetic experience of encountering the deep structure of physical law. Paul Dirac, who predicted the existence of antimatter on the basis of the mathematical beauty of his equations, believed that mathematical beauty was a reliable guide to physical truth. Einstein spent much of his later career searching for a unified field theory, driven by the conviction that the universe must be, at its deepest level, simple and elegant, a conviction that had no purely empirical basis, but that seemed to him to be demanded by the character of what physics had already revealed. These experiences, the experience of mathematical beauty as a guide to truth, the sense that the universe's order is not arbitrary but fitting, the feeling that understanding the universe is somehow like reading a text rather than simply cataloging data, are not proofs of God. But they are experiences that push against the purely deflationary account of the universe as a collection of matter following arbitrary rules. They suggest that even the most rigorous materialist scientists are, in their moments of deepest engagement with their subject, experiencing something that their official philosophical commitments do not fully account for. And this brings us to what may be the most important point of this entire discussion. The debate about God, the formal, public, philosophical debate between scientists and theologians is one thing. But the lived experience of human beings in relation to the universe, to each other, and to whatever it is that lies beyond the edge of our understanding, is another thing entirely. And the lived experience is, in a very real sense, the more fundamental thing. Because the formal debate exists within the context of human life, and human life the actual experience of being a person, of loving and suffering, and hoping, and grieving, and wondering is what the debate is ultimately about. Most people who believe in God have not arrived at their belief through a careful evaluation of the philosophical arguments. They have arrived at it through the experience of prayer that felt answered, of community that sustained them through crisis, of moments of beauty or grief that seemed to open onto something beyond the ordinary surface of things, of moral convictions that felt not like preferences, but like discoveries, of encounters with other human beings whose dignity and worth seemed self-evidently real in a way that no abstract argument could either establish or destroy. These experiences are real. They are part of the data of human existence, and any account of the universe that dismisses them as illusions as nothing more than the products of brains evolved to find patterns, even where none exist, needs to explain why those experiences are so consistent across cultures and centuries, and why they so regularly produce outcomes of compassion, of courage, of resilience, of moral seriousness that are, by any reasonable standard, genuinely good. This does not mean that every religious claim is true, or that religious experience is immune to criticism, or that the long and often ugly history of institutional religion, its violence, its intolerance, its corruption, its use as a tool of oppression should be overlooked or minimized. These things are real too, and they must be weighed honestly. Religion has produced both the most inspiring and the most terrible things in human history, and any account of it that ignores either dimension is not being truthful. But the question of whether God exists, the pure philosophical question, stripped of all the historical and institutional and political complications that surround religion, is not answered by pointing to the evils done in God's name, any more than it is answered by pointing to the goods done in God's name. The question is about reality. And the honest answer, after all the arguments have been heard and all the evidence has been considered, is that we do not know. We genuinely do not know whether there is a God, whether the universe has meaning, whether consciousness survives the death of the body, or whether the moral convictions we hold most dear are discoveries about the nature of reality or projections of our own preferences onto an indifferent cosmos. What we do know, what science has magnificently revealed, is that the universe is vaster and older and more structured and more mathematically elegant than our ancestors could have imagined. We know that the matter we are made of was forged in the hearts of dying stars. We know that the atoms in our bodies have existed for billions of years and will continue to exist long after we are gone. We know that we are connected, in the most literal physical sense, to every other thing that exists, sharing the same fundamental particles, the same physical laws, the same cosmic history. We know that the capacity for understanding that we exercise when we do science, when we formulate equations and test them against the behavior of nature and find that they work, is itself one of the most remarkable features of the universe, a feature that the universe has somehow produced within itself, through which it comes to know itself. Whether any of this points toward God, whether the universe's capacity to know itself through the minds it has produced is evidence of something more than an extraordinary coincidence, whether the mathematical elegance of physical law reflects something like rational intention behind the design of reality, whether the persistent human experience of transcendence is a genuine glimpse of something real or a beautiful and comforting illusion, these questions remain open. They are the deepest questions, and they deserve to be held open with honesty and humility and wonder, rather than prematurely closed by either scientific hubris or theological dogmatism. Let us now think about what Stephen Hawking's life and legacy actually mean in this context. Because Hawking was not merely an argument. He was a person, a specific, irreplaceable, extraordinary human being whose life told a story that no equation can fully capture. He was a man who, stripped of almost every physical capability that most of us take for granted, continued to engage with the deepest questions about reality with a passion and a precision that never diminished. He found, in the abstract mathematical structures of theoretical physics, something that sustained him, something that gave his life meaning and purpose and direction in circumstances that would have broken most human spirits. Whether he would have described that sustaining something as beauty or truth, or simply the satisfaction of understanding, the effect was real. The mathematical universe gave Stephen Hawking a reason to keep going, a reason that was powerful enough to sustain him through 55 years of progressive physical deterioration with his intellectual force and his humor and his appetite for understanding essentially intact. There is something almost theological about that, even if Hawking himself would never have described it that way. The universe, through its mathematical structure, spoke to him in a language that he could understand and respond to, and that dialogue sustained him. Whether the universe was speaking because it is the kind of thing that can speak because there is something more to it than particles and forces, something that reaches toward mind and meaning, or whether the speaking was entirely on Hawking's side, projected onto a cosmos that is in fact utterly silent and indifferent, is precisely the question we have been exploring throughout this discussion, and it is a question that Hawking's life and work illuminates without definitively answering. What his work does definitively establish is that the universe is rationally ordered in a way that human minds can access, that the laws governing its behavior can be formulated with mathematical precision, and that those laws, traced back as far as physics can reach, do not obviously require any external agency to explain why they are as they are, and why the universe that operates under them came to exist. This is a genuine and important intellectual achievement, and it deserves to be celebrated as such. What it does not establish is that the universe is meaningless, that consciousness is a mere epiphenomenon of physics, that the moral dimension of human experience is an illusion, or that the question of God has been answered. These broader claims, sometimes made in Hawking's name, go beyond what his physics actually shows, and recognizing that distinction, honoring what Hawking actually achieved without inflating it into claims that the evidence does not support, is itself a form of intellectual respect for the man and his work. The question of God in science, when properly understood, is not a competition in which one side must win and the other must lose. It is a conversation, a long, complex, often difficult conversation that humanity has been having with itself for as long as it has been capable of having conversations. Science has contributed to that conversation the most rigorous and reliable method for understanding how the physical universe works that human ingenuity has ever devised. Religion has contributed to that conversation the accumulated wisdom of millennia of human experience with the questions of meaning, value, purpose, and transcendence. Philosophy has contributed the conceptual tools needed to think clearly about the relationship between these different domains and the different kinds of claims they make. None of these contributions is complete by itself. Science without philosophy degenerates into what has been called scientism, the confused belief that science can answer all meaningful questions, which is itself not a scientific claim, but a philosophical one, and a poorly argued one at that. Religion without science is cut off from the most reliable method we have for distinguishing what is true about the physical world from what we merely wish were true. Philosophy without both science and religious experience floats free of the grounded human realities that give philosophical inquiry its urgency and its stakes. The richest and most honest engagement with the questions we have been exploring in this discussion requires drawing on all three traditions, taking seriously what science has established about the physical universe, taking seriously what human beings across all cultures and centuries have experienced in relation to the sacred, and using the tools of careful philosophical thinking to navigate the relationship between these different streams of insight. This does not mean that every answer is equally valid, or that the boundary between rigorous thought and comfortable fantasy can be ignored. It means that the questions are genuinely hard, that the evidence genuinely underdetermines the conclusions, and that the appropriate response to that situation is not the false confidence of either the dogmatic atheist or the dogmatic believer, but the genuine and productive uncertainty of a mind that takes the questions seriously enough to live with them rather than prematurely close them. And there is something to be said for that, for the posture of genuine wondering, of staying open, of continuing to ask rather than insisting on an answer that the evidence does not clearly support. Because the universe, the more deeply we look at it, consistently reveals itself to be larger and stranger and more surprising than we expected. Every time we have thought we were close to a complete account of reality, the universe has shown us another layer beneath the one we had reached. Every time we have thought we understood the rules, we have discovered that the rules we understood were approximations, valid within a certain domain but breaking down at the boundaries, replaced by deeper rules that we had not previously suspected. This pattern, the pattern of successive approximations of each layer of understanding revealing a deeper layer beyond it, is not just an interesting historical fact about the development of science. It is a clue about the nature of the universe itself. It suggests that the universe has depth upon depth, that its structure is not flat and simple but richly layered, and that the final account of what the universe is and why it exists and what it means may be something that lies not at the end of a single intellectual tradition, but at the convergence of many scientific and philosophical and theological, each contributing something that the others cannot provide. In the face of all of this, the extraordinary accomplishments of modern science, the genuine puzzles that remain, the persistent human experience of meaning and transcendence, the deep and unresolved philosophical questions about consciousness and value, and the grounding of moral obligation, what is the wisest posture we can adopt? Perhaps it is this: hold the question of God honestly. Do not claim more certainty than you have, in either direction. Take seriously what science has established: the vast age and scale of the universe, the power and universality of natural laws, the natural origin of life and of human beings, the absence of any need for divine intervention in the specific physical processes that science describes. Take seriously also what science cannot tell you: why there is something rather than nothing, whether the universe has meaning, what consciousness is, and whether it reduces to physics. What grounds the moral claims you make on other people and they make on you? Take seriously the experiences that billions of human beings have reported of prayer, of transcendence, of moral conviction that feels like discovery rather than invention, of love that seems to reach beyond what physics can explain. Take seriously also the history of religion, its failures and its crimes, as well as its inspiration and its consolation. And then live. Live as fully and honestly and compassionately and thoughtfully as you can, in the light of everything you know and an honest acknowledgement of everything you do not know. Because the question of God, finally, is not only or even primarily a theoretical question, it is a practical question. It is a question about how to live, what to value, how to treat other people, what to do when life is hard, how to face suffering and death and the loss of people you love. And on those practical questions, science and philosophy and theology, at their best, all point in a similar direction, toward honesty, toward compassion, toward humility, toward wonder, toward a seriousness about the claims that other people's existence makes upon your own. Whether the universe that produced us and surrounds us and will outlast us by billions of years is ultimately a place of cold indifference, or of something more, something that a human being might, with appropriate qualification, call divine, we do not know. We may never know, but the not knowing, if we hold it honestly and live fully within it, is itself a kind of wisdom. It is the wisdom of a creature who has looked as carefully as possible at the universe around it, and has found it to be a place of tremendous beauty and order and mystery, a place that rewards the deepest attention we can bring to it, a place that persistently suggests, without ever quite confirming, that the attention is not wasted, that the wondering is not foolish, that the reaching towards something beyond the immediately physical is not entirely reaching into empty air. Stephen Hawking spent his life reaching toward mathematical truth, toward a complete understanding of the universe, toward the deepest laws that govern everything. Whether he was reaching toward God without knowing it, or simply toward the universe as it actually is, which is magnificent enough, is a question that his equations cannot answer and his life does not resolve. But the reaching itself, the extraordinary human capacity to orient toward what lies beyond our current understanding, and to pursue it with every available resource of mind and heart that reaching is, perhaps, the most important thing about us. It is, perhaps, the thing that makes us worth taking seriously as inhabitants of this remarkable universe. It is, perhaps, the thing that makes the question of God worth asking at all. Because if we were purely physical systems, running through our programs and outputting our behaviors without any genuine orientation toward truth or beauty or meaning, the question of God would never arise. It is because we are the kind of creatures who can ask it, who feel compelled to ask it, who find that the question will not leave us alone no matter how many partial answers we accumulate, that the question has the weight and the urgency and the depth that it does. And that compulsion, that inescapable orientation toward questions that exceed our ability to answer them, may itself be the most important clue we have about what kind of universe we live in and what our place within it ultimately is. Whether that clue points toward God, or toward something else entirely that we do not yet have words for, or simply toward the irreducible mystery of a universe that is stranger than any framework we have yet developed to describe it, that is for each person to determine for themselves, as honestly and as carefully and as humbly as they can, the questions will remain. The universe will not explain itself. And perhaps that is exactly as it should be the greatest invitation extended to every conscious being in this cosmos, to keep asking, keep wondering, keep reaching, and keep living in the generous and demanding light of what we do not yet know.